Okay. All right. Now mass. Let's talk about mass. Okay. And by mass, what I mean is the total amount of material contained in a planet. Okay. The total amount of material contained in a planet. And this could either be small or large, okay? A high mass or a low mass, right? So which group of planets would you guess probably has more material inside? Would you guess that the Jovian planets have more material inside, or would you guess that the terrestrial planets have more inside? You'd probably guess Jovian, right? Because they're bigger, and we typically think of bigger things having more inside. Now, I'm not going to say if that's right or wrong. Let me ask you this. Is the amount of mass something has something you can see? Is the amount of material inside of something you can see by looking at it? Yes or no? So it turns out it's not something you can see, right? It's not something you can see. Let me put it this way. Check me out. Look at me. Look at me. My mass would be how many kilograms I am, right? It's the amount of material inside of me. You can't know that, right? You can't know what's going on inside of me. You don't know how much in here is fat or how much is straight muscle, right? Here's a hint. It's mostly fat. It's mostly fat in here. There's not a lot of rippedness. There's no definition here. But technically you can't know what my mass is just by looking at me, right? So what would you have to do to figure out how many kilograms I am? What would you have to do? What would you have to do with me to figure out what my mass is? Yeah, you're going to have to figure out some way to measure it. You're probably going to put me on a scale, right? You're probably going to put me on a scale in order to measure my mass. Because here's the thing. Why can't you just know the mass from looking at something? Well, we said that the mass is the amount of stuff contained in that object. But what's the only part, don't overthink this, what's the only part of an object you can see when you look at it? Any object. What's the only part you can actually see? Yeah, the outside. The outside, right? You can only see the outside, the outer parts of any object. So when you're looking at me, you see my skin and like my shirt, right? You don't see what's inside. I could be totally hollow inside. Maybe I'm a fake person. Maybe I'm just a hollow shell of a human being and it's all air inside of here. That wouldn't look any different than if I was just an actual human being, right? As long as you made the outside look right, right? So we can't tell what's inside from looking at it. So we have to figure out a way to measure it, okay? So check this out. So somebody says they're behind in the stream. I'm sorry about that, but just keep on following along. You're okay. Now, check this out. If you wanted to find my mass, you'd put me on a scale. Can we put Jupiter on a scale? Can we put Jupiter on a scale? No. It's just way too big. It would take way too much money to make a scale that big, and when you get that big, things are going to get weird with trying to put it on that actual scale. So we got to figure out some other way to indirectly figure out the mass of these planets. And luckily for us, there is a way. Okay? Because mass causes a force. Which force does mass cause? If something has mass, somebody's on the right track here. Somebody's on the right track. If something has mass, what force does that mass create? Gravity. And somebody said Kepler's third law. Essentially, we're using Newton's law, which is, again, a more complete way to describe Kepler's laws. So you were on the right track. But we can use the gravity of a planet to determine how much mass it has. Because, let's see if we can put this together. If a planet has more gravity, does it have more or less mass? If a planet has a stronger gravity than the Earth, does it have more or less mass than the Earth? More, okay? So basically, if we can figure out how strong the gravity on a planet is, we can figure out how much mass it has, because more gravity means more mass, okay? And there's a few ways we can do that. We can drop things on the planet so that we can measure how fast they fall. And by looking at how they fall, we can figure out how much gravity they have. And we can just look for things that are already orbiting the planet. So what's a thing that could orbit a planet? What do we call big balls that orbit these planets? Will we look at how many objects orbit it? Yes. We'll talk about how many moons each of these has eventually. We'll get there. But moons. If we look at the moons of these planets, not all the planets have moons, but if a planet has a moon, the speed of the orbit of your moons is determined by how much gravity you have. The more gravity that planet has, the faster those planets will orbit at the same distance as from other planets. So, in terms of gravity, it turns out, here we go, the Jovian planets have a higher gravity than we do. Let me put that on here. So, relatively high gravity. And terrestrial planets are considered to have low gravity. So, a planet like Earth is considered to be a low gravity planet. We don't typically think of this as being low gravity because this is the gravity we're used to, right? The gravity here is strong enough to kill a human being, but that's still considered low compared to the amount of gravity that the Jovian planets have at the same distance, right? So, putting that together, were we right that Jovian planets have more mass? Yes or no? Based on this information, were we correct that Jovian planets have more mass? That was our guess. Yes, we were correct, right? We were correct here, okay? So Jovian planets, because of their high gravity, means they have a high mass. Whereas terrestrial planets, because of their low gravity, they have a low mass, okay? My point, though, instead of just going straight from the guess and saying, hey, we're right, is pointing out that just because something is bigger doesn't mean it necessarily has more mass. That's not going to always be the case. But in terms of the planets, the bigger ones are a higher mass, okay? So we were right. Now, some of you guys did guess that the terrestrial planets have more mass. And I saw a lot of people talking about that. And they're like, oh, but the terrestrial planets have a lot of rocks. And a lot of you guys were saying the Jovian planets have a lot of gas, okay? But here we're not talking about what kind of mass you have. We're talking about how much of it you have, okay? So what you were thinking of instead of mass was density, okay? Density. When we're talking about the density of something, what are we basically talking about? If you say something is very dense, what are you saying about it? If something is very dense, what does that mean? Like, what does that mean in, like, a normal... How could you explain that to a little kid? What does it mean to be dense? Let me restart this while you guys are answering that. Compact. That's a good way to put it. That's a good way to put it. If something is dense, it is packed tight, right? And if something is low density, it is not packed tight. It's very, very spread out. So your density has less to do with the total amount of material you have and more to do with the type of material you have, okay? It's very, very thick. You can sort of think of thick, but yeah, it's just really, really packed tight. That's what being dense means. So density depends on two things, okay? It depends on two things. One of them is your size, and one of them is your mass, okay? Your size and your mass combined give you your density, okay? To help you understand what I mean, let's say I had, let me put this aside for a second. Let's say I had two buckets, okay? Two buckets that were the exact same size, okay? And they were identical buckets. And in one of those buckets, I put, let's say I put 3 rocks in that bucket. But in this one, I packed in that one. So in this area, I only have 3 rocks, but in this one, I have a lot more than 3 rocks. So which one of these, let's call this A, let's call this B, which bucket has a higher density right now? They have the same area, they have the same size, but B has more rocks, so B would be denser. So if I pack more mass into the same volume, the same size, then that would make the density go up. So in general, if the size is the same, more mass would make your density higher, right? Because you would have to pack it in tighter to get the higher mass in that size, right? But on the other hand, size also matters here when you're talking about distance, or is it density, right? If you were to take an object, let's say you were to take one object and you were to puff it up to a much bigger size. If you took one object without changing what it's made out of and you just blew it up to a much bigger size, what's going to happen to the density? If you take that object and spread it out, is the density going up or down? Yeah, the density is going down or lower, right? So, in terms of size, bigger size means lower density. Okay, so if we put these together, bigger mass would mean a higher density, as long as the size was the same. Increasing size, though, brings your density down. And the reason that those are both related is another way to say density is to say it's the amount of mass you have per size. Mass over volume, okay? So, here we go. If we go back to our list, this is not our list. If we go back to our list, if we were just looking at mass, we said higher mass gives you a higher density in general, if they are the same size. But are the terrestrials and the Jovians the same size? Are the terrestrials and the Jovian planets the same size? No, right? No. So if they were the same size, then Jovians having higher mass would mean that they have a higher density, because if they were the same size, that higher mass would mean more stuff's packed into the same area, right? But Jovians are also much, much bigger. And in fact, the difference in size is so large that even though Jovians have more material than us, they are spread so far out that their density is low, Okay, so let's add that onto here. This is the first thing that the terrestrial planets get to win at. Jovian planets are low density, whereas terrestrial planets are high density. And again, it's because of the kind of material that these planets are made out of. What kinds of material are terrestrial planets made out of? Let's see if you guys can throw me out some types of stuff. What kind of stuff is a terrestrial planet mostly made out of that gives it such a high density? I don't need an exact type of material, but what kinds of stuff? What's a terrestrial planet like Earth made out of? Rock. Yep, terrestrial planets have a lot of rock up ground. That makes sense. You're basically saying rock. Rock, metal, all of these things. We can think of a terrestrial planet as mostly solid. And we have some liquid rock inside of our planet. But even that liquid rock is actually very close to being pretty solid, okay? For most of it, a lot of it. So mostly solid. The terrestrial planets, mostly solid.